So you guys have been working on this full stack application, containerized full stack application, and today we are going to get it deployed to AWS. So this is not an advertisement for AWS or anything like that. This is the default suggestion that we have, and there's a couple reasons for that. But if you, for whatever reason, want to use something else, if you want to use, there's a dozen other services like AWS out there where you can basically rent a server or rent a computer. So go ahead and do that if you want, but AWS is the biggest one and you get 12 months free. So it's possible to do this for free. So that's basically why we do that. But if you can do this on AWS, you can do this on any other provider. Okay, so create an AWS account. And before I do that, I just want to take another look at the application to make sure that we kind of understand what's happening. And that I'm going to use as an example this one. So you guys are writing your own, but using this one. So I'm going to go here. I have basically the same thing in my personal repo. So I'm going to clone that down. Nope, just updated my system. So okay, so let's look at the diagram real quick. So the diagram for this application is, I think the sequence diagram is the best way to understand this. So what is a client?
It's like basically our local machine, right?
Yeah, so it could be a local machine. Um, yeah, so there are more specific things. So it's not just your whole machine.
It's like basically anyone accessing the front end or that IP address.
Yeah. So it depends on kind of how you think about this. It could be a person doing something, it could be like your computer, but more specifically, it's the program that's executing the request. So typically that's going to be a browser, but Postman is also a client, curl is a client. There's lots of other clients. So this is whoever, whatever program is making the request, but yeah, you can think of that as a user or a browser or a computer. And then that request goes to a web server. So can someone tell me about the web server?
Um, is that like the Nginx thing?
Yes.
Um, so Nginx is just like handling all the HTML, CSS, and our JavaScript.app files. And it's we're using Nginx just because it's like, if I remember correctly, how do I phrase it? It's better at like handling requests and like putting out the request for that data and getting that data back, and it handles it all a lot better than just trying to like run it not with that.
Yeah. I think that's basically correct. Yeah. So Nginx, it's a specialized program that runs, and its job is to take in HTTP requests and make responses, and it can do all kinds of other things. There's all kinds of configuration and fancy stuff you can do. We're going to keep it very simple, but it can handle lots of requests simultaneously, and it can route traffic. If you have lots of different other endpoints, it can act as like a proxy. So or a proxy or reverse proxy. You might hear those terms. But basically its job is to just be the initial entry point for any request from the front end. The architecture will be slightly different, slightly better later on, but for now we're doing it this way. So when I make, when I'm on my web page and I go to, example.com, that initial request is going to go out to, some web server somewhere, often it's Nginx or something, Apache or whatever. And then that request is going to go in, it's going to get handled, whatever logic happens, and then I'm going to get a response back. What about this? Let's see. Corey, can you tell me about the API component?
It's the interface between the program and the user, I guess is the
Okay. Yeah. So yeah, in general, an API, an application program interface is like, it's an interface or the way you interact with something else. So what is the person, or what is the entity doing the interaction, and what's behind the API?
It talks to, I mean, it could be embedded on like a website, like some of the ones we were working with before, and so it's basically talking to the client and then the web server, or not the web server, I guess, but what it has its own database or whatever it's talking to, and then it sends that information back to you.
Exactly. Yeah, so the API is basically the intermediary between the client and the database. So if you want, if you want to have an interesting app that actually saves data and shows data, it's not just, hard-coded static website, you need to have some kind of data persistence. And a database that's what it's for. And an API layer is basically a way to take in some kind of request, do some kind of processing, and almost always have some kind of database interaction, whether you're getting information from the database or you're updating something in the database or adding a new record somewhere in the database. So that's the API's job. It's an API, application program interface, and it's an interface because it's a middle layer between a client and a database. All right, Joyce, can you tell me about the database?
Yeah, so the database is like SQL or any other type of database that HPPI can communicate to and pull the information from.
Okay, cool. Yeah. So are there different kinds of databases?
There are non-SQL databases, like is DBMongo one of it?
Yep.
I think I only know these two.
Okay, cool. So just out of curiosity, so I'll make this more of an interview question. So what's the difference between a relational database and a NoSQL database?
Isn't a relational like basically tables that have relationships with each other? And in NoSQL, it's kind of like not a table structure. It's kind of storing the data in, like, I don't know, different ways, basically.
Yeah.
JSON, right?
Yeah. So I think if you think of it as being like a JSON, like a JSON object. So if you have a relational database, which is what we're basically going to learn about here and what we've learned about, you have very structured data. It's very structured. I have if I have a record somewhere, I know that it should have this column and this column and this column, and they should be this data type, and it should have a foreign key relationship to this other table and so on. So it's very it's very structured. Every piece of information is kind of, I know what it's supposed to be. You have a NoSQL, and there are pluses and minuses to that, like everything else. A NoSQL database is more just like an object. So, I might, if I have a user, for example, user may or may not have certain keys, and I can add keys and I can remove keys, and it's a lot more flexible, but also a lot less consistent and predictable. So there are use cases for it. We don't need to talk about that, but yeah, cool. All right, so that's the basic idea. And in terms of the interactions, a request, the client will initiate some kind of request, basically like, I want to go to a web page. And going to a web page means make an HTTP request to a server, a web server, and that web server gives you back an HTML document, which your browser then nicely renders for you, so you don't even know that it's HTML. And once you have that HTML document, let's say I click a button somewhere and I make an API request, right? So I start here on the client. I'm going to make a request to the web server. I'm going to get some HTML document, basically. And then from my browser, I'm messing around with this HTML document. And now I click on a button, which, requires some additional data. So the client then makes a request, using JavaScript to this API. And the API will then take in that request and parse through it. It's like, okay, well, what kind of request is this? What kind of data do you want? What route are you trying to go to, etc. So whatever logic the API has to process that request, it's going to process it. And probably it's going to then take that request and create some kind of query, some kind of SQL statement. And that SQL statement will get executed against a database. And that database is going to, send its results back to the API. And then that API is going to take those, that SQL, the results of the query, and turn it into something like JSON that can be used later. So this response from the database is going to get turned into JSON, and then the API can finally send that back to the client, usually as JSON. And then your front end, your JavaScript, your front end will parse through that JSON and do whatever it needs to, like adding elements to the DOM or whatever. So that's the basic structure and flow of everything. Any questions? All right, so I'm gonna take, let's take a look here at this app. So the structure of the app is gonna be similar to what you guys are making. So you've got 3 different containers. We have the front end, the database, and the API. So I look in the front end, I have a Docker container. And let's see. No, can you tell me what's happening in this Docker container or this Docker file?
So you're getting Nginx, and then you're copying your index into your container, your index style app. Yeah.
Okay. So why am I doing this?
It's just copying the whole front end into your container, so you can have it.
But why am I copying it here specifically?
I'm not sure.
Okay. Does anyone else happen to know?
Is that the path?
It is a path.
Yeah. Is it the path where the files are located?
Um,
Index HTML style at CSS.
so
I'm just
I'm
kind
gonna go ahead. Yeah, I'm gonna go ahead and I'm just gonna pull down an Nginx container. So Docker run and dash IT. Fine. Actually, it doesn't have bash, so I'll do that. Okay, so now I'm here in this container, and if I do ls, I've got some stuff here. So where is this /user/share/nginx/html?
I guess you could CD into a user,
Okay,
and then there's probably some sort of Nginx directory in there.
okay, there's some stuff here. There's a
I
share,
guess not.
share, ls. Got a whole bunch
Yeah,
of stuff,
there it is.
but I have nginx, so cd nginx, ls. Oh, I have this HTML thing, cd HTML, ls. That's interesting. I already have an HTML document here. I also have 50x.html. So I wonder what this index.html file looks like. How can I see what this looks like? Cat, yeah. So I could use cat. So cat index.html. And it says, welcome to Nginx. If you see this page, the Nginx server is successfully installed and working. So this looks like it's like a default welcome page. So what I'm going to do now is I'm going to go ahead and I'm going to run this, but I'm going to do port mapping. So I want to actually see if I can get this web page. So run -p, and then I think I'll do 3, 4, 5, 7. Why not do port 80? I assume it's listening on port 80, but I don't know. We'll have to find out. Okay. So why am I seeing all this output here? I mean, I can't use my terminal now, right?
I just
So you just started the server.
Yeah.
Yep. So I started the server and I did not start it in daemon mode. So that's why I'm seeing all this, and that's why I can't use my terminal, which is fine. So I'm going to create a new tab here. I'm going to do Docker PS, and I can see that this container is now running. So what I'm going to do, well, I can try going to localhost, and look at that. So this is that index.html page that we saw. So it looks like, well, would anyone like to speculate or draw any conclusions based on that? So the question, why do we copy this stuff over into this specific directory?
Is that like Nginx's directory that is just defaulted that it runs like those are just all the files it grabs for when it runs the server.
Yep.
So it knows just
Exactly. So the answer is that's just how Nginx does it. It's not like something magic about it. Really nothing to do with Docker. It's just how Nginx does it. So this is the default way that it operates. You can change that configuration. How would you know this? You would just have to read the documentation. So this is not, knowledge that you can just derive by being super smart. It's just some arbitrary thing, and that's how they do it. Okay, so Nginx, we're copying all this stuff over because by default, without changing any other configuration, Nginx will just serve up whatever is in this folder. So that's why we're throwing that in. Okay, now let's look at the, okay, we'll look at the database next. So the database, what's happening with the database?
It's doing the same thing. It's just copying a init into the entry point, Postgres entry point for that image.
Yep. And so this kind of is a Docker thing, but there's this file here, and this is set up to just run any scripts that you put in this folder. So that's how this particular Docker container works. So this is like, it's a little different than the Nginx case. The Nginx case is more of just, that's how Nginx is. This is a little bit more, this is how this official Docker image works. If you put any .sql or any .sh files here, they will get executed when the container is run. So what do we want to execute when the container is run? I want to create a database and some tables and populate it. All right, so let's look at the API now. Let's see. Almost called on Tiffany. Ken, can you tell me about this Docker file?
I guess you're getting the version of Python you want. The working directory, not super sure.
Okay.
You're just copying all the files that are in that API folder into the source, I guess.
Mm-hmm. Okay, good. So anyone else want to fill me in on the work there?
Is the source just referring to the actual current directory where the Docker file is?
Not exactly. So
Isn't it that's where it's gonna be run from after it got copied over?
yeah, so that's also partially correct. So where is this happening? Is this happening on my local machine, or is this happening in the container?
Be in the container, correct?
Yeah, so this line is about what's happening in the container. It doesn't actually have anything to do with my local file structure here. So work there is basically a combination of mkdir and then also setting the path to be this. So if this directory doesn't exist, it's going to create it. So it's going to do mkdir. It's going to create the directory, and then any subsequent command, it's going to start from here. So instead of starting from the root of the container, it's going to start from here /source. So this next command, so where is this and where is this?
The requirements.txt is in our API folder.
Yes. So this is the local file that we have on the computer.
And then I imagine that // is just targeting the source.
Yes. So this is in the container. So here it's from and to. So this is the standard like Linux command format, from and to. If I copy a file, I copy it from somewhere to somewhere. If I, whatever. So that's a common thing, from and to. So from is a local file, and then to is somewhere in the container. And this somewhere this is now basically a shortcut for /source, because we created this work there. Okay.
And then the run after that is basically taking the requirements.txt that we just copied into the container, and it's installing everything that's specified in that text document.
Yep. Okay.
And then we're basically putting the server and the IP address that's specified in that DBIP document, and we're also copying that into the same place as the requirements.txt.
Okay. So this is a little odd. What's going on? What's going on with this?
Not sure, but I saw in the server that we referenced that IP. I think, is it at the bottom? Or no, there it is, yeah.
Yeah, does anyone else know what's happening here?
In the start all command, it runs some lines to get that. Yeah.
Okay, good. So this is really like the entry point for everything. So we've got 3 containers here, and we need them to run, and we need them to like cooperate with each other, right? So our application isn't just one thing. We got 3 containers, and we somehow need these things to interact. So this script is just a way of coordinating that a little bit. So first thing we do is we run this db.setup. So I can go here and just look at that real quick. Nothing we haven't seen. It's going to build it and run it. And then here, it's a little odd, but so we're just executing this command to pull out the IP address of what?
The database.
Yeah, exactly. So we're pulling out the IP address of the database container. And then we're going to run the API and the front end. So why do we need the IP address of this with the database container?
Because it's what the API uses to access the database.
Exactly. So the API container needs to talk to the database container, so it needs to know its address, right? Now, this is a little hacky, and we're just doing this as a temporary thing. Later on, we're going to use another tool called Docker Compose, which will handle this kind of stuff for us. But for now, that's what we're doing. Okay, so the API needs to talk to the database, so it needs to know the address. So it gets that here, and then it can now create a connection to the Postgres database. So I have my API container, and it knows how to talk to the database container. So it can, create connections and make requests and get data. What about the front end? Who does the front end talk to?
Front end.
The client side, wouldn't it?
What was that?
The client side, wouldn't that be on the client side?
Okay, yeah. So the front end container will communicate with the client. So it gets a request and it will send a response. You can look at the the diagram here again. So the API talks to the database. The web server talks to the client. And then who talks to the API?
Client.
Yeah. Again, that's how this is set up right now. Later, it'll be a little different, but for now, that's what it is. So the client talks to the API. Where is the client? I see a folder for API, database, and front end.
The client can be either like in the terminal using curl, or if we open up the web browser, let me use that.
Okay, so can you tell me more about the web browser? So if I want to go to this, very fancy website, what is the client going to be?
The index.html file.
Yes, exactly. So it's a little odd in some ways because we have these components, but then inside of the front end component we have this, which is basically going to get sent to the client, and so any requests to the API are going to get made from where?
From the browser or from
Yeah.
the web page?
Exactly. From the web page, meaning from the JavaScript that gets served to the client. So in this case, here's what we're doing. So if I have all these containers running, like on my local machine, then I go to localhost. Well, where do I go? I can look at the Docker file. I don't see anything there. What about this start script? It's going to call this setup. Sorry, it's going to call start frontend.sh. So I go here. So if I want to get this HTML document, where do I have to go on my computer? What do I have to type into the URL bar?
HTTP localhost, and then port 80.
Yes.
It looks like in your case.
Exactly. And because 80 is the default port, you actually don't have to do it. But yes, if you want to be explicit, then port 80. So localhost port 80. And I know that because I'm mapping, when I run this web server container, I'm mapping my local machine's port 80 to the internal port 80 of the Nginx container, which is where it's going to be listening by default for HTTP requests. Okay, so I go to localhost port 80, I get all of this junk, right? I get the index, the HTML, I get the app.js, and the styles.css. Great, so now I'm looking at a web page, and I want to click around on the web page, and now I want to make a request somewhere. So I make a request to localhost 8000. So I'm going to look at the API, and I go here. So why am I allowed to go to port 8000? Well, because my application is listening. I have port mapping from 8000 external to 8000 internal. So that's how all that is connected. And I'm just going to run it locally to make sure that it actually works. Okay, and I will do /start all. This will take a minute, so if anyone has a question.
Yeah,
On
I
your
got a,
fro- Oh,
go
go
ahead.
ahead, Chris.
I got a quick question. In the API Docker file,
Yes.
what if you wanted to copy a file into a subdirectory of source? Would you have to create a new work directory kind of, or can you just do copy requirements.txt / and then type something in?
Yeah, that's a good question. So I'm not exactly sure if you would have to do a separate like command where you create a directory inside here and then do it, or if it would implicitly. I'm actually not 100% sure. We could test that out real quick. Yeah, let's test that out. Yeah, right here. Create a Docker file here. I'm just gonna kill all this.
It must not be that practical if you don't know how to do it. Or there may be a reason to.
Yeah, so let's give it a shot. So I'll do this. Actually, I'm gonna use Nginx because it's a smaller image. And then if I want to do copy slash, and then I'll also try and copy let's see if this works. So how do I run this Docker file? How do we run a Docker file?
Docker run.
Okay. And then I'm just going to use bash, so dash IT. See if this works. So this doesn't work. What do I have to do? So before I can run the container,
You got to create an image.
yeah, so I have to build it. So Docker build, and I think that should be sufficient. Docker images. So there we go. I'm just going to use this image ID. I didn't give it a name. So I can do Docker run dash IT that and shell. So now I'm here. Sorry, let me do this somewhere else so we can see it better. Okay, so we're running this container that we built, and we want to check out these directories to see if we have anything. So ls, I have, so notice that I'm starting from the apples directory, right? So anything I do by default is going to start here, including, you know, when I enter the container. Like it's cd, and I'm here, but this is my root, and then I have apples, so cd apples. And it looks like okay, so this is interesting. It didn't actually do. So how do I find out what kind of thing this is? Looks like it's not a directory.
Is it type they use?
Actually, I'm not sure. Type. One thing you do is ls dash L. Actually, sorry, ls dash L. And I can see here that. So let me create a directory so I can show you. So mkdir. Now I'm going to run ls dash L, and a directory you can see that has this little D. That's the first thing. So this is a file. So oranges is a file. I'm not sure why that happened. Yeah, that's really not what I would have expected to either error or actually create the directory. Instead, it creates a file. So I'm baffled. I don't know why I did that. All right, so let's get back here. So yeah, so let me run this script again. Actually, I'll do it from here. Okay, so I'm going to start everything up. All right, so how do I see what containers are running?
Docker PS.
Docker PS.
Yep. So what am I expecting to see if I do Docker PS?
3 containers, so the database, API, and front end.
Yep. So Docker PS, and I have 3 containers, so that's good. Then I'm going to go here, and I should be able to go to localhost, not this, but just 80, and it works. And can I make a request? Yes, I can. So I can use the API, and let's just take a look at the network just to make sure. If I go to a particular one, I can take a look at that request. Go to the response headers, the request header. I'm going to localhost 8000. Notice that this is a request to localhost 8000, which is the API container. Everything's still accessible on localhost. Okay. Questions about that? All right, let's take a 10-minute break. Well, yeah, 10-minute break. When we come back, we'll actually look at deploying this.
I actually had one question.
Yes.
When it comes to the front end part, right, on Nginx, let's say you had a multi-page front end. Will you put all those HTML pages in there as well?
Yeah, so we're actually not, yeah, you would. Yeah, and you can specify different routes. So I don't want to get into the config stuff. And when we actually use this, for real with React, React has a router, a built-in way to handle routes that make it pretty easy to set up.
Okay, cool. All right.
Okay, so by the way, I made a mistake with the previous example. We're trying to figure out this work there thing. So I didn't have a closing, a final slash here. And so what it was doing is it was saying copy this file into the work there, which is apples, and then name that file oranges. So that's what it was doing before. If you include the closing slash, then it will actually do the expected thing, which is create a directory called oranges and then copy the file over. Okay. All right, so this is running. So I want to have us think about communication. So the IP address. So if I'm running this locally, everything is on localhost. When I put it on the server, what do I need to change, if anything? So looking at the diagram here. So if I make a request from the client to the web server, if I'm running this locally, then it's going to be localhost port 80. And then if I make a request from the client to the API, it's also going to be localhost port 8000. And then the API is going to communicate with the database, but it already knows actually the IP address of the database.
We'd have to change whatever the AWS is, whatever the IP address is.
Yeah, exactly. So, we can run our application locally, but when we go to deploy it, we have to change one or two things. And that's basically called like configuration. So that IP address is configurations. And there's different ways of handling stuff like that. You want to, one of the reasons to use Docker is that you can have the same thing. Like if this runs and works locally, it should also run and work on a server. So there shouldn't be any extra stuff you have to do, just, changing some configuration. And there are different ways of handling that. We're going to kind of do it just manually for now. So what we're going to have to do is eventually we're going to have to find all the places here, namely, so when the client makes the initial request to the web server, that's just happening in the browser. So that doesn't have anything to do with our application directly. So that we don't have to worry about, but here we do. So if from within the apps, the app.js file, we need to make a request to the API. Well, we can't go to localhost because it's not on localhost. It's going to be at the IP address. So this right here is going to have to change. So we'll just keep that in mind. All right. So let's go to the actual README. So I'm going to go to my AWS account. And I'm going to log in real quick.
Hey, Chad, are you going to cover environmental variables today, or is that kind of later in the course?
Not going to cover it today, but we will definitely be covering it later. Okay. So that's how we're going to handle stuff like this, the like localhost versus whatever IP address we're going to end up having. Okay, so when you first log in to your AWS account, it's probably not going to look exactly like this because I have recently visited, and you will not have recently visited anything. But you can always find stuff by you can either go to services, which you'll have a bunch of stuff here, or you can just type in the specific thing you're looking for. And the only thing we care about now is EC2. So I can go there, or EC2, virtual servers in the cloud. So what we're going to end up doing is we're going to create an instance. We're going to create an EC2 instance. And all that means is we're basically going to we're going to rent a virtual machine somewhere. So Amazon has a bunch of data centers in different places, and we're just going to ask them to rent a little chunk of one, and it's going to handle a bunch of boilerplate for us. So to do that, I'm going to go under launch instance. So all this stuff should be in the README. If you want to follow along, you can, but it's up to you. All right, so launch instance, I'm gonna click on that. And then when I want to create this instance, I have a bunch of choices to make. One is like, what operating system do I want to use? So I'm just going to give this a name. It doesn't really matter. And then the base image, we're just going to use the default, which should be Amazon Linux 2023. There's a whole bunch of other ones. There's, Ubuntu, Red Hat, Debian, etc. And there's also a whole bunch more. So if you don't need to worry about it, but there's a ton of these, and you can make your own. There's actually ones you can buy as well. Okay, and we're going to use this by default. Notice that it's free tier eligible, so you shouldn't have to pay for that, which is great. And I'm just going to keep most of the defaults here. And then the instance type, just go with the default, which is T2 micro, which is free tier eligible. So this is a small thing, but we don't need any more than that. And then this key pair login. Does anyone happen to know why we need a key pair login or what that is?
Is that for security?
Yeah.
Like basically like I don't know, I think one private key, one public key, if they match, then you can log in.
Yes. Yeah, exactly. So it's a certificate. It's actually the same basic system that HTTPS uses. There's a private certificate and a public certificate. And I don't have a detailed understanding of the nitty-gritty, but it's a way to ensure that you can encrypt. You can encrypt and decrypt. So when you do this, AWS is automatically going to generate a public-private key pair, and it's gonna store, it's gonna store whatever it needs on the machine, and then you're gonna get a file that you can use to access. And by access basically means SSH into this server. So since we're creating this, we don't want to just like go to the web page. We actually have to go into the computer and set everything up, right? We need access. We need like access to the computer. So that's why we have this. Okay, so I'm gonna create one. I'm gonna call it Fullstack, and you can use the default rsa.pem. Create key pair. Let me. Sorry, just 1 second. Not sure why that. Also click on something else. Let me just move this. This. Okay. All right, so now this should be on my desktop. It doesn't really matter. So I'm actually gonna so I have this fullstack.pem and I'm gonna put it into, I think this is where I'm working out of. Okay, so I'm gonna just drop it in here. Okay, so now I have this .pem file, and let's take a look at that. So you don't need to really know anything about it, but here's the private key. So this is something that you would like never ever show anyone. You keep it secure somewhere. Okay, so I've got that there. So this will allow me and only me to access this server. All right, so I've got my private key. So now we've got network settings, and we're gonna be very insecure and not really care about anything right now. So I can choose my IP, but that doesn't really matter. So allow SSH traffic from my IP. So that's how we're going to get in there and actually install everything we need and set everything up. And then I'm going to click this, allow HTTP traffic from the internet. This is just the security setting for AWS. So this will allow us to go to port 80 on our machine. And then you have to worry about this. So that should be fine. I'm going to do launch instance. Will take a minute to spin up. Meanwhile, I'm going to go here back to the instances, and I can see the list of one. I only have one, but I can look at the properties of this particular thing and notice that it automatically gave me a public IP address, which is this right here. So this is really the only thing we need to worry about in order to access the machine. We're gonna have to do one other thing. So first off, I'm gonna go change the app, right? So I'm gonna go update this, basically update the configuration here. So I'm gonna go to the front end app.js. Instead of localhost, it's now going to be this. So I'm gonna save that, and then I don't want to, it doesn't matter really for our purposes, but you never ever want to push that. So I'm going to add this to the git ignore. Okay, so git add, git commit, git push, origin name. Okay, so now I've updated my app, and one thing you can do is just create another branch. So you'd have like a deploy branch and a develop branch or something like that, and you could only just so you can separate that configuration. Otherwise, it's kind of annoying to keep switching back and forth when you're developing. Okay, so we've got that going. And the other thing, well, I'm just going to leave it like this for now, and we'll see what happens. Okay, so now I'm going to try and connect to this instance. So I need to SSH into here, and if you choose connect, first off, this is running now. It just takes a minute to spin up. I go to connect. It's going to basically give me this command that I can execute. So you don't have to click on connect to instance, but this is just, if you're lazy like me, you just copy that. So what I'm going to do is I'm going to go here first, and I need to be at the same level as my fullstack.pem. So I am. Notice that there's some other instructions that we're ignoring right now. So I'm going to SSH in. And so I'm basically saying, hey, I want to, I basically just want to like do stuff on this server. So I'm gonna click yes, you don't need to worry about that. And then I get this very scary warning, unprotected, private key file, and so on and so on. Permissions for fullstack.pem are too open. So what does that mean?
I mean, anyone can do anything they want to it.
Yeah, how do I know what permissions my fullstack.pem has?
It's like ls with like the a tag or something.
Okay, yeah, it's actually -L. That's what we saw. So this will oops, sorry. Sorry, ls-L. So fullstack.pem, it's got read, write, read, and read. So this is too open. So this is a security precaution that this OS has. So it's telling us that we have to change this. So we'll run this command, chmod 400. Oops. Yeah. And now if I see this again, you'll notice that I think this is only the root user can read this. So we went from basically anyone can read it to only the root user can read it. So that should be fine. Now we're going to SSH in again. We're going to run this SSH, include this certificate, and here is basically the IP address that we want, and then this user @ so this is a common syntax. So I want to SSH into this as this user. Okay, and now I'm in. So now I'm actually inside this computer, which I don't know where in the world this computer is, probably somewhere on the East Coast, but it doesn't really matter. So it's just like being inside of a Docker container. It happens to be on your local machine somewhere, but it doesn't really matter. It could be anywhere. So we can do, anything we can do. We can ls, we can echo, right? So we're just on another Linux machine somewhere. All right. In order to actually get this set up, we need to install some stuff. So this is just an operating system, doesn't really have anything. It just has, the usual general tools and utilities, but we need some specific things. We need Docker, and we need Git, because at least for now, we're going to clone our code down here so that we can run it. We need those two things. Then we're also going to include Docker Compose just for the sake of consistency, even though we don't really need it right now. So I'm going to copy this. And you don't need to worry about this, but we're just going to install Git and Docker and then do some permission stuff and then install Docker Compose. So you can just copy this and run it as a block. Okay, so installed a bunch of stuff. I should be able to do like git -- version. Okay, and Docker -- version. Okay, so I have Git and Docker installed here now. That's really all I need. So now what I'm going to do is I'm going to clone down my repo, which is right here. I'll just copy this. So I have my personal repo. So git clone and cd. So now I have my code here, and I should be able to just run this script just like I did locally. So if I do /start all.sh, first off, I want to double check and make sure that I have this IP address stuff figured out. So I'm going to cd into front end, and then I should have updated the app.js. So I'm going to do less app. So I can see that it's right there. So that top line is actually configured correctly. I'm going to press Q and get out of that. If I needed to modify it, I don't know if Vim is on here, but so vi app.js. Okay, it is. So if I forgot and I didn't want to like copy it over, I just want to make a quick change, you can use Vim. So that's this is the kind of thing that I occasionally will use Vim for. I don't really develop with it, but it's handy for this kind of situation. Okay, so I'm gonna all right. So everything looks good, so I should just be able to run it. So it's that /start all, and let's see what happens. Okay, so I installed everything properly, like Docker, everything has the right permission, so I can at least run this. So if my application is working locally, I can basically be sure that it will work. Will work here as well. Okay, so this will take just a minute to get everything going. So let's take another look at our instance. There is one change we're gonna have to make. We'll look at that in a second. And so this IP address, we should just be able to copy this IP address and then go, instead of this business, just go right there. So right now we have an issue because this is not up and running yet. But now it is. Okay, so let's make sure that these containers are running. So Docker PS. I have these 3 containers running, so that should be good. And now I go to this IP address, and any of you could go to this IP address, and you should be able to see the same thing. We've got a small problem here. I can get this my initial request to get the HTML stuff works. However, the API stuff is not working. Notice that these requests so unfortunately, this is how a lot of AWS stuff works. Things just don't work. Yeah, I'm not getting really an error or anything like that. It just doesn't work. So I can see that the request URL is blah blah blah, my IP address :8000/all. So I can try, maybe there's something with my browser. So I don't know. Let's try Postman. Maybe we'll have better luck here. Okay, so I'm gonna make a GET request here. And we get the same thing, it just kind of hangs. Yeah, that's odd. I'm gonna close this. Maybe curl. Let's try another window. I'm gonna stop that, and I'm gonna add the verbose flag -b. So it's, making that initial request, and it just kind of hangs there. So this is a tough thing to debug, but if you have that situation with AWS, it usually means that there's some permissions issue somewhere. And in our case, when we set this up, we said any HTTP, basically any HTTP request is gonna be okay. We're gonna allow that, but that implicitly means port 80 because that's the default HTTP port. We, however, are trying to make a request on port 8000, which we did not specifically allow traffic to. So we have to do that. You're going to go here to security, and you click on the security group here. This is kind of a pain, but you just have to do it. And then edit inbound rules. We're going to add a new rule. So currently, here's the traffic that we're allowing to our server. We're allowing, so this is, I guess, my IP address. We're saying you're allowed to SSH in if you're coming from this IP address. You can also make an HTTP request on port 80 from anywhere. But we need to make a request on port 8000 from anywhere. So I'm just going to add a new rule. I'm just going to allow all traffic. This is not secure, but it's fine. Okay. And I'm going to save this rule. So all traffic from anywhere.
Did you add port 80 earlier, Chad? I must have missed it.
Not explicitly, but it asks you if you want to allow HTTP traffic. And that implicitly means on port 80. So when you create the instance, one of the configuration options, there's a little radio button, or I think it's a checkbox that says, allow HTTP traffic. And if you check it, then it will create that rule.
Okay, because it was set up in Docker as 80. Did you just know that?
Yes. So it's
Okay.
Yeah, that was a deliberate choice. So 80 is the default HTTP port. So you could have done anything wacky, but the basically standard thing on the internet is to make port 80 that port.
Gotcha. Thanks.
Okay, so we have this new rule, so we should be allowed to get data now. So I'm going to clear this, and I'm going to try to make a request, and now we can actually do this. I can get a specific person. So looks like our web page now works on the internet. So anyone can go here and then use our website.
This may be getting ahead a little bit, but how do you turn that into a www.geteveryone.com?
Yeah, that's more involved. We're not going to do that, in part because it costs money. So we're not going to make anyone do anything that costs money. But yeah, you have to register a domain name, and then you basically you can use AWS to do that. There's something called Route 53. There's also other providers, and you'd probably want to create what's called an elastic IP, because if you associate a domain name with this IP address, and then you turn off you delete this machine and recreate another one, it'll assign it a different IP address. So there are a few things that you're going to want to do, but we're basically just going to stick with this. It's not the most flashy marketable thing, but it'll work, and it doesn't cost money. And a step beyond that, if you're going to go down that route, you can also add a certificate and make your site HTTP. Notice that I get this not secure warning here.
And that box chat, when you click the HTTP that defaults to support 80, you didn't click the HTTPS. Was there a reason for that?
Just because I knew that we weren't going to use that, but
Okay.
HTTPS is port 443 by default, so it's the same thing. It'll just open up port 443.
Okay.
But yeah, so we're not going to get into like making your own domain name and setting up secure certificates. It's a little bit of a pain and it costs money. So that's basically why. But you're free if you want to give it a whirl, especially for your personal projects. Feel free.
How much does it cost roughly? Is it like a per month
It
kind of
varies.
subscription?
Yeah, I think it's yearly for the domain name. There are free. There's group, I guess, called Let's Encrypt. So you can get free a free certificate, but I think it expires every 3 months. You have to set up a process to like automatically update that, which is doable. It's just a little more complexity. And then it depends on the domain name. So if you have a domain name that no one else is sitting on, then it's probably going to be like $10 a year or so. But if you want, Coca-Cola.com, then you're gonna have to pay for it.
So, okay, this is completely unnecessary, I guess, but who are we paying for these? Like, who is the, like, so if you have like a random domain name, let's say, I don't know, something becomes popular, some random, no one knows about it now, but you saw it coming, so you bought the domain. Like, who are you paying for that, essentially?
Yeah, that's a great question. I don't actually know all the details. At the level of certificates, there are a few certificate authorities, like they're called certificate authorities. So if I go, for example, here, and I click on this, and I should be able to connection secure. Let me see. Yeah, so I should be able to look at the certificate here. And so here's the certificate. So this is certificate for, AWS. Actually, they have it for the region as well. And then it's issued by Amazon RSA. And sometimes you might have, you can go up higher in the chain. So, one authority issues a certificate to another authority, which then issues certificates to someone else, which then issues certificates to you. So let me try something else. So and that is just arbitrary. There's just a few groups, and it's like, how do you become one of these certificate authority groups? I don't know. I guess you got to know a guy or something. But there's only a few of them, and it seems kind of arbitrary. But let me see. Like,
They should make like physical titles for domain names like cars. That'd be cool. You could post it, frame it.
Yeah, but
because I remember when, like, I mean, it's died down, but like Ethereum was like, you can build things on Ethereum, and it was this period of time where like people thought it was going to blow up, and everyone was buying up like a lot of .eth domains, hoping that they could sell it in the future when people start to build on Ethereum.
Yeah,
I was just like, who are you paying for this? And I guess you pay the Ethereum people.
Yeah, I'm not sure. I don't know if it's like the people who do DNS. Yeah, honestly, I just don't know. I'm not sure. I could look that up. Okay. So that is how you deploy something. So the most important part of this process is getting it to work on your local machine. If you think that it's broken on your local machine, but you'll just go ahead and deploy it anyway, it's not going to work. So make sure, go through the normal development process, piecemeal, get everything incrementally working. Once it's all working locally, then you go and deploy it, and you're probably going to run up, you're going to have some hiccups there, which is fine. So let me also show you. So now, I'm running it, blah, blah, blah. So I'm done with it now. If you want to just leave it running forever, that's fine. You can. And if you ever wanted to like update the application, you could just SSH in and then, you know, spin down the container and spin up a new one or whatever you want to do. But I'm done with this now. I just wanted to do it for the test. So I'm just gonna turn it off now. So I'm gonna go to actions or instance state and terminate instance. And now it's just gonna power down. So for the AWS free tier, you get like basically you can have one of these running constantly, and it's fine. But if you want to have like 2 or 3, it's a good idea to like shut one down if you're not using it. In general, it's just a good habit to get into. Like if you're not using something, then shut it down. Because that's how, you know, that's how you get charged for stuff that you're not aware of. All right, that's all I got. If there are no questions, go ahead and keep working. So make sure you get it working locally and then try and get it deployed. And at the end of today, we'll do a little show and tell.